Hello, so this is an introduction to quadratic functions. It is a discussion about what makes a quadratic function different than a linear function. It is the first step that we take in Algebra 2. So what is a linear function? So we have been talking about linear functions since Algebra 1. So linear functions are just lines. They have that constant rate of change. So that's their slope, the m. Okay, they form lines. They're straight. They could be positive, negative. They could be flat. General form for this is an ax plus by equals c. That's the standard form. But you most likely will know it as y equals mx plus b, where m is the slope and b is the y-intercept. These are things that we have been studying throughout math. And up until this point, everything that we have studied has had a linear function to it. Now, we are going to go into quadratic functions. Quadratic functions are slightly different. So there's not a constant rate of change. So they don't form lines, they form parabolas. So they form in the shape of a U. And you'll notice that the standard form or the general form of a quadratic function is ax squared plus bx plus c. So the biggest thing that gets added in there is that ax squared. So having that x squared in there adds that quadratic function into it. So anytime that you see an x squared in an equation that's all simplified, that is a quadratic function. So how they look. So you'll notice a linear function. This is just a graph of a linear function. The slope is up 3 over 2. Y-intercept is -4. You can see that's this straight line. While a quadratic function, which we will be studying for the next unit, is in the shape of this U. All right. And you'll see that there is that squared piece to it. So the biggest thing with standard form is that this ax squared is called the quadratic term. The bx is called the linear term because it just has the x. And c is called the constant term, or the constant. Constant being just a number because that's never changing. So how do we determine if a function is quadratic or linear? So if it has an x squared, if it has a squared in there, then it's quadratic. If there are no x squareds and there is an x, okay, then it is linear. If it's just a number, there's no variables, it's constant, it's not changing. But we never classify anything as constant. It's either quadratic or linear, because something that is quadratic is just a line anyway. And I will go into that more later. So the steps to classifying functions. So when you're given an equation, first off, you have to simplify it. So you have to simplify the expressions before you classify it. So there's some simple steps that you will have known from solving equations. First step, you distribute. If there is a distributive property, you combine like terms, get all the variables together, combine the numbers by adding or subtracting, and then once you simplify, you just determine, okay, is there an x squared? Is there just an x? And that's how you determine if it's quadratic or linear. And then you can identify the quadratic, linear, or constant term based on the simplified expression. So again, if it has an x squared, it's a quadratic. If there are no x squareds left on the simplified, then it's a linear. The first term, okay, is always the x squared term, and that's the quadratic. The middle term, the x, is the linear term, and just the number is the constant. If there are no terms, if there is no x or x squared left, then you just write none. So here are some examples. So example one, you'll notice we have to distribute. So the first thing that we're going to do is we're going to distribute these numbers in, and we're going to be left with 3x squared minus 6x minus 3x squared plus 6. Okay, because this term right here, this right here is negative. So when I multiply by this -2 here, I get that positive 6. So you'll notice that I can combine these two terms. So 3x squared minus 3x squared, well, those cancel out. So what's left is my simplified term of -6x plus 6. So that is a simplified function. So now what I do with that is I look at classifying it. So if I have -6x plus 6, is it linear or is it quadratic? Well, there are no x squareds here, so it is linear. Okay. Quadratic terms, well, if it's linear, there's a none here. The linear term is -6x, taking that negative with it, and the constant is 6. So that's all you're doing with this. Okay. The next example, you'll notice I don't have to worry about this 4x squared, but I do have to distribute this 2x in. So what I'm going to do is I just write 4x squared. Now, 2x times x. So because there's the x's are here and they're multiplying each other, it becomes plus 2x squared. So whenever you're multiplying variables together, it adds an exponent. Okay, so x times x is x squared, and then minus 8x. So now I can combine my x squareds, which becomes 6x squared minus my 8x. And that is all I can do and simplify to finish. So now I go into my classifying. So you'll notice that there is an x squared. So this is quadratic. I'll just write quad there, okay? Quadratic term is 6x squared, and my linear term is -8x. And there is no just number, so I write none. Okay? The next step is distributive property, but it's a special distributive property. Some people will know this as FOIL. Okay, so it's basically you have to distribute this 2x to both of these numbers here. Okay, so it's called first outside. Okay, and then you have to also distribute this 3 to both of them. So some of my students actually find it easier sometimes to write this out so that it's a little bit more clear. So it's literally 2x times x minus 4, and then plus the 3 times the x minus 4. So some people refer to this as FOIL. I refer to this as a double distributive. So all I'm going to do is I'm going to distribute this 2x in. And just like we talked about in the previous example, 2x times x adds an exponent. So this becomes 2x squared minus 8x, because I'm multiplying both of those. And now I distribute this 3 in, and I get plus 3x minus 12. So what you'll notice in here is that my x squared term is alone. There's nothing that I can combine, but I can combine this middle portion. So my final simplified equation or expression becomes 2x squared minus 5x minus 12. So what you'll notice is this has all three terms, ax squared plus bx plus c. So now I have this equation. So is it linear or is it quadratic? It is quadratic because it has an x squared term. My quadratic term is 2x squared. My linear term is negative 5x. And my constant term is negative 12. And you just have to make sure that you have those signs in there. So that is how you determine if an expression or a function is linear or quadratic. And that is what your practice is going to be on. Now, you might ask, why are there not constant functions? So this is not officially part of your notes, but this is questions that often come up. So constants are just numbers. They don't change ever. Okay, so that's why they are called constants. They are never changing. It's not like a variable x where you can plug in a different number and that value changes. So constant functions, they're really aren't constant functions. So you actually have graphed these. So x equals a number, you'll notice is a vertical line, or y equals a number is a horizontal line. So you notice that they are both lines, which means they are actually technically linear because they form that straight line. And if we go back to linear functions, linear functions have a constant rate of change. So that constant rate of change for a y equals a number is actually 0. So if you remember, there's a 0 slope to it, so it is not changing, it's staying constant. An x equals a number, you will learn, is actually not a function because of the shape of it. It's a vertical line, so it actually has an infinite rate of change or no slope. So that is why there aren't things called constant functions. If you could please complete the practice, ask any questions that you need. Thank you very much.